assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Here we're going to, for part A, note that the angular frequency would be equal to the square root of the spring constant divided by the mass. This would be the square root of 1500 newtons per meter divided by 0.55 kilograms. Sorry, my apologies, 0.055 kilograms. And this is equaling 165.1 radians per second. Now, we are going to consider the most direct in each part of the. So for part A, we're going from x sub 1 equaling plus 0.800 times the amplitude or the maximum displacement at time t sub 1. And then 2, essentially, x sub 2 equaling plus 0.600 times the amplitude at time t sub 2. So we can then say that we're going to use equation 15.3 omega times t sub 1 plus the phase constant phi would be equal to arc cosine of 0.800. We can say this would be equal to 0.6435 radians. Omega t sub 2 plus phi would be equal to arc cosine of 0.600. This would equal 0.9272 radians. So subtracting the first of these equations from the second, we arrive at the fact that we can get a new workbook. This would be omega times t sub 2 minus t sub 1. This would be equal to 0.9272 minus 0.6435. This is going to equal 0.2838. And using the value for omega being 165.1 radians per second, we find that the change in time, t sub 2 minus t sub 1, is going to be, this would be radians. This would be equal to 1.72 times 10 to the negative third seconds. This would be our final answer for part A. Now for part B, we're going to let, this would be x equals negative 0.800 times the amplitude or the maximum displacement at time t sub 3. And we'd be using the exact same method of calculating this. So here we would be saying that omega times t sub 3 minus t sub 1, this would be equal to 2.4981, where essentially arc cosine of negative 0.800 is going to be equal to 2.4981 radians minus 0.6435 radians. This is giving us 1.8546 radians. And so essentially dividing by, again, 165.1 radians per second, we find that the change in time t sub 3 minus t sub 1, this is going to be equal to 11.2 times 10 to the negative third seconds. This would be our final answer for part B. That is the end of the solution. Thank you for watching.